So what I wanted to do is to reproduce the kicks multiple times. And you can see, instead of just seeing one, you're seeing a whole stream of them. And what makes them the kicks is the lack of signal between in the stream. Okay, and you see there's these guys that punch up. See, there you go. See that guy right there? You see it? Okay, so that is a stream of kicks. This guy here is 3 horizontal runs, and I'm really not doing anything with them at the moment, but reading these 2. And I'm also reading this one down here, which is the red stream on there. Standard sine wave. And we're talking 340 volts. Let's see if we can get down there to prove it to you. There you go. And what I did was I fired them off with a, what do they call these guys? Complex, a CFL, compact fluorescent light transformer. Puts out 2,000 volts, and I put it outside to put the leads this way so that they were 90 degrees to this guy to show you that a coupling happens. Anyway, so the red is being read the red signal on the scope is being read off of this lower line here. These 2 guys, I did have frequencies going into, but I don't right now. It's not necessary. I can turn it off and on and nothing happens. But basically what I've got is this guy here. That's CFL starter. So that is the spark gap, which produces the kicks in the stream whenever the thing fires. That's where the kicks come from, a spark gap. It is a testicoil system. So what I've got here is this is 2 halves, and I've got this half as in series with this inductor, in series with this cap, and back through to itself, which is a tank circuit isolated unto itself. And that's what's on the yellow, just the tank circuit. And what you see on that is, well, you can't. I can, but you can't. Here you go. It's 330 volts on that tank circuit. And that tank circuit's coupled across from this inductor off this spark gap and the CFL. Now this is nasty. I'm not going to touch it. This is one nasty transmission of very, very high frequency energy. And so what I did was, as this CFL fires against these windings here, they're all compacted to a compressed impact point here on this lead, which is in parallel with these guys. That makes it a transformer of sorts. And then it goes back through. That's what's on the tank. So that is how, there's 2 ways. The tank is being fed from this lead, is being picked up from here. Let me rephrase that. The tank is picking up this energy from this, okay? And then as this thing cuts across this way in the compression zone, then this guy picks it up too, and he's part of the tank. So I've got this tank interleaved with this high compression zone in the center of this spool. And there's nothing in the spool itself. It's all air. It's all air. So the CFL pulls up 2,000 volts, and I'm picking up, this time 378 volts. And as this CFL warms up, you see the stream gets fuller and fuller. But on this isolated tank, that still does not diminish. The sine wave is still there. Now, what comes out of the CFL is a sine wave, but it's 2,000 volts. That spark gap there changes it from a sine wave to a very high frequency kick stream. Whoops, let's go the other way. Let's bust it out here. See? There's your kicks. There's thousands and thousands of them. There's your hash on your DC. See it? Isn't it sweet? See the pattern? Look at that. Now the reason why you just saw the pattern change is because the CFL light and that just triggered. So obviously it's coming through this system. See? Let's tighten it back up again. Let the camera catch up. There you go. Now, I see a lot of kicks in there, and we're talking 230 volt, 240 volt kicks. See the number right there, VP on blue? Right there. So that's your stream of kicks. That's what everybody's looking for. And it's done through this mechanism. And you'll notice this looks like the large TPU. Exactly. Because the only way to find out what SM was talking about was to duplicate the big one, because there's not that much hidden in the big one. What's in that black box is 2 stun gun circuits with 2 transmission heads. I have 1 transmission head here, and it causes it to flip-flap back and forth as it fires the triggers for the circuit. Boom, 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 boom. And then that causes back here, boom, 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 boom. Up and down, up and down, up and down. And this is an 8-foot ball of magnetic field. Spazzing out, just like that. Let the camera catch up. See that? That's my hand going in. That's my hand. I'm not grabbing it. I'm just sticking it inside and out. And then I move it out. And it changes the signal. So lo and behold, if I was to stick a clamp-on ammeter in there, what do you think would happen? Hang on, let me get it. Okay, so we've got our little clamp-on ammeter here, and we've got, it's a Sperry, and it's like at 400 amps. What does 400 amps look like? Nada. Wonder why. Okay, let's look at 40 amps. Oh, let's look at the voltage. We've got, can you see that? I got 1200 volts. Correct? No decimal. The decimal's down there. That's 120 volts on that clamp-on. 600 volt AC reading. Let's put the amps. Of course there's no amps. The amps are probably smaller. But the voltage shows up, which means that this is strictly charge potential, which is what we want. So, there's your stream of kicks. That's what everybody's looking for. The only way to get it is with a spark gap. Comprende? So you can see this thing is starting to look similar to SM's large TPU. And obviously, there's not much to it. There's a couple things missing off this, but I'll put those on later. That's all for now. Merry Christmas.